So let's look at identifying quadratic features in parabolas. And as we get started, let's review a parabola real quick. You might be familiar with one, or you might need a real quick review. So got a quick sketch in on your notes page and up on the screen too. So a parabola is a curved graph that represents the graph of a function. So if you kind of connect the dots that you have there, like I'm going to do on the screen, remember a parabola is kind of a U-shaped graph, kind of goes like that, and it can be anywhere on the XY axis essentially, but you get a U-shaped graph like that. And this is a parabola that can either open up, or you can have parabolas that kind of go this direction too, where they open down. And what we're going to look at here is kind of making sure we can identify the key features in quadratic parabolas, basically. So let's go through some more vocabulary. Let's look at the vertex. So I've got another parabola sketched in. And what is the vertex? Well, the vertex is the peak point on a parabola. And this can be either high or low depending on which way your parabola is. Here's what I mean by that. I've got that one sketched in. But let's check in this double parabola example I've got. And let's find the vertex on these. So on the first one, we're going to look at the peak point. You'll notice that this parabola here is basically going up, got an up kind of shape on this parabola, and the vertex is right there. It's already been identified for you basically, but if you throw a dot there, we can kind of put the coordinate that shows up on. Remember, origin's right there at 0, so that vertex point is at basically 1, -4 is where you would have the vertex of the first example, 1 and -4. And then on the second one, we've got switch colors here. We've got that, and it's marked pretty clearly too. So the vertex there is going to be here at +3 there, and then at basically 4. So basically a 3, 4 vertex. And we're just looking for the peak point. Vertex literally means peak on your parabola. Axis of symmetry is the next term we're going to look at. So axis of symmetry, we're going to actually use the vertex, which we just talked about. So axis of symmetry is a vertical line that divides the parabola into two congruent halves. If you think about the term symmetry or symmetrical, it's when basically something is divided into even halves. And so when we look at lines of symmetry, if we're using our first example, if I came in here, use a light blue here, and drew a line right down where the vertex is, try to make it as straight as I can. Basically, I would divide that parabola into two congruent even halves. And I can do the same thing over here on the right. Dash line coming through, dash line coming through. And kind of like we could fold this thing in half. I think even on your notes paper you've got a little fold where it can show you axis of symmetry when you fold and you get even halves. This is what we're looking at. You fold it, you always needs to run through the vertex, so make sure it runs through the vertex, which we did right over there, vertex there, vertex there, and that's going to show you where the axis of symmetry is. So there's an equation for axis of symmetry. It's not a big old long equation. All we're going to do is write x equals. We're basically going to have, like we already did, our vertex is going to be identified. We've got our axis of symmetry going down the center section here. Remember, it's got to go through the vertex. So I'm going to come all the way through here. And basically, what x equals is how we're going to write it. At what value of x does the axis of symmetry basically go down? As we follow this line all the way down, it's crossing right at just 1x, which is right there. So x is going to equal 1, and that's what we mean when we say equation for axis of symmetry. Not real crazy, just a basic x equals. Same thing on the right, so identify again our vertex right over there, and then axis of symmetry kind of coming down straight through the vertex. And what x basically are we going down the whole time with that? We're going right there at 3. Right at 3. Hopefully you can see that. So the axis of symmetry for the second example is x equals 3. Alright, so y-intercept. We've got some other parabolas here. Looking at the y-intercept, we're looking at the point where the parabola intersects the y-axis. Pretty straightforward, okay? So remember, the y-axis is your vertical axis going up and down here. And so where does the parabola cross the y-axis? Well, basically on this one, it's not easiest in the whole world to see, but you can see it's kind of crossing right here. I'm putting a blue line right on basically negative 1, 2, 3, 4, negative 5. So negative 5 is essentially the y-intercept of the first example. And check out the second one. Pretty basic too. Again, we make sure we're looking at the right axis. Y-axis is going up and down, vertical. Where is it going across? Not exactly straight on the line. It's a little above. So I'm probably going to say it's right above positive 4. So we could probably say, hey, this is probably going at like 4.40 or maybe 4 and 2/5, something like that. Those are both the same value. So that's what I put. We put 4.4 as the y-intercept on the second one. So just finding where the parabola crosses the y-axis on y-intercept. So if that's y-intercept, you could probably see where x-intercept is going. That is the point where the parabola intersects the x-axis. So here's what's different. There's going to be 2 points for the x-axis. So if you've paid attention to your parabola, you'll see that as your parabola kind of goes through this U-shape, it actually it crosses the x-axis. This is your x-axis right here, your horizontal axis. Actually crosses twice. So I'm going to take out my little mark and come back in green. And you'll see the 2 spots right over here where the parabola goes across the x-axis, and we're basically just going to identify those. So on the left, I've got negative 1, 2, 3, negative 4, and 1, 2, 3. Those are my x-intercepts on the first example. And then on the second one, I've got my x-axis again. Let's identify where this parabola is going across at negative 2 there. So I've got negative 2 right there. And then on the other side, 1, 2, 3, it looks right there, 4. Yeah, negative 2 and 4. So not too difficult to identify, but you can have 2 points. You have 2 points if your parabola is going up or down. You're going to have 2 points on your x-intercept. If you see zeros, so if you're asked to identify, locate the zeros, you are essentially doing the same thing as finding the x-intercept. This is to show where the parabola of the function equals 0. And all you're really doing, and I'm even going to write it in, we're going to say this is the same, write it neatly, same as, pen doesn't want to work, same as x-intercept. So, and I'm saying this because it is sometimes asked in a different way how to find the x-intercept, and that might be find the zeros in the parabola, and we would just be doing the same thing. We'll find where the zeros are in here, again, right over here at negative 4 and 3. Be some zeros there. And in the same spot as the last example here, going across at, I think that's negative 2 and 1, 2, 3, 4. Right over there, fix my comma. So finding the zeros is the same thing as finding the x-intercept when you're identifying that on a parabola. Okay, so maximum value and minimum value, and we're going to talk about maximum value first. You're going to have either one or the other. So you've got a parabola. The maximum value is going to be the highest point, which is really going to be the vertex, on the parabola. If the parabola is going down, we're looking at the highest point, and you kind of see where that's going. Our parabola here is going down, if I come all the way around. So basically, we want the highest point. We want the vertex point, essentially, of the parabola when we're looking. And you basically just want to put in, we just want the y value, okay? And you can write that in there. We can just put y value for that. Write that a little neater, y value. So the maximum point right over here for our first example is kind of going across right there at 1, 2, 3, 4, 5. So the maximum on that one would just be 5. We're not going to put y equals 5. We don't need to put it in an equation form, but we just need the y value. We don't need the x value. When you find values of a function, you're basically always looking for the y value, so that's what we want there. So that's going to be the maximum value. So the reverse is then going to be the minimum value. So minimum value is the lowest point on the parabola if the parabola is going up. So got a kind of an upward parabola here. What is the lowest point? Looks like it's right down in that section, right at -5 y. And again, we're just looking for the y value. I'm going to write that in one more time. Y value to make sure that's kind of hitting home. And that's all we want. We're looking at maximum and minimum values, okay? So maximum, minimum, and let's do a real quick review, real quick practice. I sketched in a real quick, kind of a rough parabola there. And let's see if we can get the vertex, the axis of symmetry, put an equation for the axis of symmetry, y-intercept, the x-intercept or the zeros, and then get either the maximum or the minimum values. Well, let's go with the vertex first. So vertex, we need that already kind of marked out for us, which is nice. It's right over here on the vertex. Where does that occur at? Well, basically at 1, 2x, -3y, we have the vertex. So I'll put 2, -3 is our vertex. All right, cool. Axis of symmetry. Well, axis of symmetry, I'll come in with our blue dashes. And remember, we're going to go all the way down this X spot, all the way through the vertex. Try to make it as straight as you can, a little straighter than I did. And we basically marked the axis of symmetry, which is good. How about the equation for the axis of symmetry? So when we go and look for the equation of axis of symmetry, what x are we going on all the way down as we drew that blue line? I think it's probably pretty clear to you guys, but it's right there at 1, 2, 2x. So x would equal 2 on our axis of symmetry. And then let's look at the y-intercept. And I'm going to clean this up just a little bit so we can see clearly. So y-intercept, remember y-intercept, we're looking at our vertical axis here. And where is that line first going straight across? It looks like right there. We're getting the parabola to go across. So that's at 1, 2, 3. So the y-intercept right over there is going to happen at 3. And the x-intercept, or the zeros. Remember, we're going to have two of them. We've got two places where the parabola is going across. And let's identify those. So the x-axis in purple I've got going across right over here. And the line is going across right here at 1 and at 3. So I'll write that in red. We've got 1 and 3, just like that for the x-intercept. And then finally, we have a minimum or we have a maximum value. What do we have? Well, we're going up on the parabola, so we're going to have a minimum value. So we're going to be looking at a minimum value. Kind of underline that. Say switch that out, minimum value that we have. And where is that minimum value occurring? Remember, we only need that in terms of y. So I'll just put, we want the y value one more time to make sure we got that. For the y value, we're basically down here at the minimum, and going in green, at -3, -3y, which is right there. So I'm going to come in and say the minimum value is at -3. And there we go. We've got our example done. Vertex axis of symmetry equation. We've got the y-intercept, we've got the x-intercept, and the maximum or minimum value.